Hello friends, in this video I'd like to solve the following problem from the Ibero-American Olympiad for university students, year 1999, problem number 1. We wish to evaluate the following series. Our sum goes from k equals 1 to infinity of 1 minus 1 over e to the power of k all over k. So this problem is rather easy. If you know the Taylor expansion for this, if you know the Taylor expansion for this series, the problem is almost trivial, but I will not use it. Instead, my hints without using this property. Well, let f of x be this function, and well, you should use the following powerful fact from mathematical analysis, that power series may be differentiated term by term. So in other words, you can take your derivative inside of infinite sum. And also recall the well-known formula for geometric series: 1 plus x squared and so on equals 1 over 1 minus x. So give this problem a try and I will see you in a minute. So as I suggested, let f of x be our series, but with x to the power of k over k. Okay. We know that our series converges. It converges for x's between -1 and 1. How do I know it? Well, there is a well-known formula for finding the radius on convergence, but if you don't know this formula, it may be also beneficial to see that we only need convergence between 0 and 1, and it's easy to establish convergence between 0 and 1, because our series, if we get rid of the denominator, it's bounded on this interval from above by geometric progression of x to the power of k. And this geometric series converges between 0 and 1. So it can be justified in this way. Okay, and now I will differentiate my function. And by the hint which I gave you, we may take our derivative inside of our series. And if I do it, I will get x to the power k minus 1, and if you look closely, it's x to the power of 0 plus x to the power of 1, x squared, and so on. It's 1 over 1 minus x. So we have our formula for our derivative, and moreover, let's notice that f of 0, if I put 0 in my formula, I have a sum of 0, so it's 0. And now I know derivative of my function. How to get my function back? Well, by integration, of course. So since f of 0 is 0, we can write, for example, that f of x equals f of 0 plus integral, which goes from 0 to x, of our derivative. F of 0 is 0, and now we have just to compute the integral from 0 to x of what exactly? Of this function. 1, or maybe put dt 1 minus t, and it's pretty elementary to see that it is natural log of 1 over 1 minus t from 0 to x, and it's just natural log of 1 over 1 minus x. Okay, perfect. So I now know my formula for f of x. Maybe let's write it again. If you know, again, if you happen to know the Taylor series of this function, this problem is almost trivial. You get this result from the beginning. Okay, and what we now want to do, we just want to plug in 1 minus 1 over e. And if you do it, we get 1 over 1 minus 1 minus 1 over e. And it's just 1 over 1 over e, so it's natural log of e, and it's 1. And we have our answer. The series, which goes from k equals 1 to infinity, of 1 minus 1 over e to the power of k over k happens to be equal to 1. And that closes our solution. So yes, I hope that you've learned something new, that you were entertained, and I will see you next time. Goodbye.